Question number 9. Which statement about a perfectly elastic collision between the two objects is correct? Okay, there is a perfectly elastic collision. What do you mean by perfectly elastic collision? It should be obeying COM and as well as COE. Okay, total kinetic energy is conserved and the relative speed of approach equals the relative speed of separation. So this part is right. This part is right, but we do not know what is this over here. Let us try to understand what is this. Let us say, for example, two objects are there which is moving with mass of m1 and u1 and mass m2 and u2. So what is conservation of momentum? It says m1 u1 plus m2 u2. After collision, it becomes m1 v1 plus m2 v2. Okay, or what I can do is I can now take m1 term separately and I can write m1 into u1 minus v1 is equal to m2 into v2 minus u2. I can write like this. Okay. Next, I will apply conservation of energy also here. How do I apply? I will write half m1 u1 square, plus half m2 u2 square is equal to u2 square is equal to half m1 v1 square plus half m2 v2 square. Okay, I'll do the same thing what we have done here. So I'll just take m1 separately. So I'll do half m1 into u1 square minus v1 square is equal to half m2 into v2 square minus u2 square I have got this. Next, what I will do is I can now divide one with the other. Okay, so I can eliminate the values of m1 on both the sides, m1 and m2. So I will divide this by this one. So when I do that, what do I get? I will get, so this half m1 u1 square minus v1 square divided by m1 u1. So what do I get here? I get u1 square minus v1 square divided by 2 into u1 minus v1 is equal to, now what do you get here? Similarly, v2 square minus u2 square divided by 2 into v2 minus u2. Now you see this u1 square minus v1 square is a minus b into a plus b. Okay, when I do this, I get this as u1 minus v1 into u1 plus v1 divided by, I cannot write here, u1 minus v1 multiplied by 2. I'll write 2 here. Or maybe I can cancel 2 here. Hey, I can cancel it here. Okay, I'll remove this 2 here. Okay, now this can be written as v2 minus u2 into v2 plus u2 divided by v2 minus u2. So therefore, see, numerator and denominator, this goes and this goes away here. So what am I left out with? I am left out with u1 plus v1 is equal to u2 plus v2. v2 plus u2 or u2 plus v2. In other words, I can write u1 minus u2 is equal to v2 minus v1. This is the way how you can prove. Okay, which says that this is nothing but the difference in the approach velocities minus is equal to difference in the receding velocities, right? Now let us look at what does it say. The relative speed of approach equals the relative speed of separation, right? So therefore, answer A is right answer. The rest of them are all incorrect. See, here also you can look at it. If you do not know how to do this math over here, just look at these options. If you are not sure about this, look at this here. Total kinetic energy is not conserved. No. Okay, kinetic energy is definitely conserved. Okay, total kinetic energy is not conserved. No, this is also incorrect. Okay, and then total kinetic energy is conserved and the relative speed of approach does not equal to relative speed of separation. So when it comes here only, you need to do the math. Anyway, you can eliminate these two and finally think about, okay, which is that you need to look into it. Okay.